The octet rule simply states that atoms gain, lose, or share electrons to achieve the nearest noble gas electron configuration, which is 8. The octet comes from 8. That's what octet means, comes from octa. Of course, there's an exception, and that's hydrogen. Hydrogen only needs 2. So if you look at hydrogen, only needs to be like helium. So hydrogen has 1 valence electron, and that would be 1s1. Well, the nearest one is, helium. Helium has 2 valence electrons, which is 1s2. And that's happy. It's a full shell now. But other ones, of course, are not satisfied with that. So, for example, if I have something like sodium, and I have something like fluorine, or it doesn't matter, whatever it is, whatever atom that the octet rule applies to, notice that sodium, it's 1s2, 2s2, 2p6, 3s1. And fluorine is 1s2, 2s2, 2p5. Okay. So what needs to happen is, with sodium, is that it only has 1 valence, but it needs 8. So we run into a dilemma here. Okay, what should we do? Should we add 7 more? Well, where are they going to come from, first of all? And that's way too much in chemistry to add 7 electrons to 1 atom. Or can you just simply lose an electron? And if it loses an electron, like this electron, which we did in the last chapter, if you lose this, it becomes, so again, if you lose 1 electron, it becomes 1s2, 2s2, 2p6. So if you add up these two, that would be 8 valence electrons. Which, by the way, this is neon. If you look at the electron configuration of neon, it is 1s2, 2s2, 2p6. And that makes sodium now what? Positive. And that's where the charge comes from. Fluorine, on the other hand, has 7 valence, but it needs 8. So what should it do? Well, it's going to gain an electron. And if it gains that electron, it's going to gain it, and it's going to add to the p orbitals, because it can take up to 6, the p orbitals. It can take up to 6. So that would be 1s2, 2s2, 2p6. So these now are 8 valence. And of course, since anything gains an electron, it becomes a minus. So that's why F is a minus charge. So that's when we learned about naming a nomenclature and you got charges, that's where they come from. So we're going to expand on this, especially when we get to covalent bonding, which are now sharing electrons. So what are the types of bondings that we're going to be concerned with? The types of, this is a very, very important table, so make sure you study it and you pay attention to it. There are types of atoms, there are types of bonds, this is what we're concerned with, and the characteristics of them. Types of atoms. If you have a metal and a non-metal, you have an ionic bond, which we talked about back when we did nomenclature. And what happens in here is that electrons are transferred, lost, and gained. So electrons are lost and gained. Second one is covalent bonds. It's between nonmetals and nonmetals. This is where electrons are shared. So they're no longer, one is gaining, the other one is losing, but they are actually shared. And finally, metal and a metal, those are metallic bonds. This is where electrons are pooled. Basically, they don't belong now to just, let's say, even they're not shared. They're now shared with among a collection of atoms rather than just two atoms. You're going to learn about this when you get to Gen Chem 2. But let's actually talk about ionic bonding. And let's begin with a very, very simple example, and then we're going to do it. We're going to do a more involved or progressively more advanced examples. So let's look at sodium and chlorine. So why is this an ionic bond? Well, an ionic bond, if you remember, if you recall, ionic bonds involved charges. So it's an electrostatic force that exists between ions of opposite charges. It's nothing but positive is attracted to negative. So positive is attracted to negative. So here's the negative charge. Here's a positive charge. How is this relevant to here? Well, let's look at the process, and you should be able to draw an ionic bond if I tell you and the process of it. So sodium, let's determine how many valence electrons does it have. Here it is. So it should have what? How many valence electrons? Valence, not total. 1. This is group 1. So let's go back. Here it is. That's the Lewis dot structure. Chlorine, on the other hand, let's go to the periodic table, has how many valence electrons? 7. 7 valence. Okay. Now, there has to be a transfer of electrons in order for the charges to appear. Plus, they need to become like the noble gases or have 8 valence electrons. So this is what happens. Sodium is going to lose an electron, give it to chlorine, and in doing that, becomes sodium plus and chloride is the resulting ion. Okay. So this one lost 1 electron, and this one gained 1 electron. And that explains the positive on sodium and the negative on chlorine or chloride. Okay. If sodium loses an electron, just like we did electron configuration in the last chapter, once again, this will be 1s2, 2s2, 2p6. And this is nothing but neon, neon, neon. If chlorine gains 1 electron, it becomes 1s2, 2s2, 2p6, 3s2, 3p6. And this is nothing but argon. So think about it this way. Here's sodium. Needs to have an electron configuration like a noble gas, and the closest noble gas to it is neon. So what it's going to do is it's going to lose an electron to become like neon. Versus chlorine right here. What's the closest noble gas to it? It's argon. So it's going to have to gain an electron to become like argon. And that's where the electron comes from. It comes from sodium. So now they're both happy. This is argon now, looks like argon. And now this one looks like neon. But are they really argon and neon? No, they're not. They're still not, they're still sodium and chlorine. They have an electronic configuration like sodium, like neon and argon, but they still have a different, their numbers of protons. So chlorine still has 17 and sodium has 11. So I know sometimes students, think that. Okay, so what happens? What happens if you have the same electron configuration? What if you have the same electron configuration or the same electrons? Well, we call this. So in this case, since Cl minus and you have argon, those are called isoelectronic. So same number of electrons, same electron configuration. Now, sodium and neon are isoelectronic. Okay, so let's continue. Where's your ionic bond? Well, here it is. Positive is attracted to the negative. So this right here is your ionic bond. So the process of losing and gaining caused it to have one side having more negative, more electrons, so that's the negative side, and then less electrons, that's the positive side. Therefore, you have your ionic bond.